Okay, this was a project which we have created yesterday. A quick recap what we did yesterday. Yesterday we spoke about what is pull, push, what is clone, how do we cherry pick, and how do we create a remote repository. So yesterday we have created a remote repository as well, and this is what my remote repository looks like. Let me give you a walkthrough. What are the options we have on remote repository right now before we move on to the pretty much advanced topics to understand what are the different types of merge and things like that. Okay, now this is the option to clone. Like when you click on repos, this is the screen which will pop up files, and in the files you can see all your source code. So this is whatever you see, just imagine that is your source code. Okay, at the top you can see which branch you are in right now, and if you go at the extreme top you can see your repository name. This is your repository name. If you want to create a new repository, you can simply click over here and you can create a new repository from here. Okay, which we'll not do right now, but eventually we'll do it in future. Okay, and now at the right hand side you can see the commits. So this is basically giving you all the commits in the master branch. All your commits which is there in the master branch, that is what it is showing you right now. Okay, then if you come at the extreme right, setup build. So using your master branch, if you want to create any build pipeline, you can do it directly from here. This is something I'll show you later in this course when we come to the section of build and release pipeline. Okay, for now just ignore it. And this is the option using which you can do a clone. Okay, now cloning is, as we all know, cloning is like creating a replica copy of the repository on your local server. So that is what cloning means, guys. So there are multiple ways to clone. Okay, now if you see, there are three ways you can find out over here through which you can clone your repository on your local system. One is HTTPS. So HTTPS is a typical user ID and password, wherein you will require a user ID and password, and when you put those information, you can clone it. SSH is more like you need to create a private and public key. Okay, so using this, so this is SSH. Mostly you'll be using SSH method, mostly on Linux system, guys. Okay, so if you're working on Linux, so this SSH method is more relevant over there, wherein you can generate your key quickly, and then using that you can clone this repository on your local. Third is generate git credentials. Over here there's an option of generate git credential. If I click over here, it will create a temporary credential for me. So where this option is relevant, this option is relevant, like suppose you have a custom application. This is for more for developers. You have a custom application and you want to use git inside your custom application for any purpose, like you might be cloning, or you might be pushing something to git, or you might be using some files from git. Could be any reason by which you're using git repository inside your application. So inside your application, definitely it is not suggested that you should go and use your user ID and password. Correct? That is not excuse me, that is not suggested at all. So what is the right way? So you can go and generate the passwords from here and you can put it inside your application. Okay, so these are the three options: HTTPS, SSH, and generate git credential. And this is IDE. If you want to clone directly to you any Visual Studio, VS Code, PyCharm, to any IDE tool. IDE is nothing but integrated development tool. Okay, if you want to put directly inside any of the IDE tool, then you can directly do it. Like if I use Visual Studio and try to clone, what it will do, it will open a Visual Studio for me and it will try to clone directly inside the Visual Studio. So this is the third option what you have. So for now we'll stick with HTTPS. Later I'll show you SSH also. But for now, let's click on HTTPS and click on this option, clone. Just copy this link, and when you come back, let me just delete this existing one for now. Okay, and let me open a git bash. And if I just do a git clone followed by the link, okay, in my case, it will not prompt me for a user ID password, guys, because the user ID password is already stored in my Windows locally. But if you're cloning it for the very first time, it will prompt you for a user ID and password. So you just need to put the same user ID password, whatever is there over here. It's the same user ID password, you need to go and use it. Okay. Now if you see this, this is my entire repository cloned on my local. Now I can work on local, I can do whatever I want, and once I'm done with my changes, I can push the changes to the remote repository. This is what all the developers will do when they start working with a remote repository. The first thing they will do, they will go ahead and clone the repository locally, get the mirror copy on the local branch. And this mirror, when I say mirror copy, I'm talking about everything, guys. The file is also cloned, and with along with this file, you will see the history. Now, if you go inside this repository and if you see the log, you'll find the complete history. So this is what mirror copy means. You have the history along with the file, along with the source code, to be very specific. You have all the source code and you have the complete history. Now you can start working on it. Okay. So this is what clone means, guys. There is one more option called something called fork. What is forking now? What is the difference between cloning and forking? Cloning, we all know that cloning will create a copy of your file on your local. Now, what is forking? Now, forking is nothing but it creates a completely independent copy of a Git repository. What it does, it creates a completely independent copy of a Git repository. In contrast to fork, wherein on the other side, the clone creates a link copy, wherein that will continue to sync with the target repository. Now, when I did a clone, just imagine when I did a clone, this is linked with my remote repository. If I make any changes over here, later it will be synced with my remote repository. Everyone agrees, correct? Later I can push it and sync with my remote repository. Wherein on the fork on the other side, this is nothing but this is a completely independent copy. Now let me just break this down into a very simple and layman term. Now, if so, take an example of a fork. We have a fork, correct? We got when we're using a fork, what exactly it has? It's like 4 teeth kind of thing. It has structure. Just imagine it has 2 teeth. So what exactly the work they're doing? They're in parallel right now. They're independently working. Like if you're trying to have a noodle, what the work they are doing? They're trying to roll the noodle in the fork, and then you're trying to consume it. Same concept over here. Forking, like just think of a developer who wants to do a parallel development, something new he wants to develop, but he is not sure that this development may end up getting into the main streamline or not, or whatever he is developing, what impact it will have. He is not sure at all. So in such cases, cloning and then creating a branch, then making changes and testing, eventually it will end up to your main branch, and if there's any issue, there's a big problem. So what in such cases, what developer does, he will fork. In place of cloning, he will fork, and fork will create a new repository. So this is my repository, Valaxy DevSecOps _1. When I do a fork, I will have a parallel repository created altogether. So in the parallel repository, what I will do, I can do my independent work, I can do my development, I can do everything, I can do testing, and everything is done. And once I think that, yeah, this is looking good, excuse me, guys. Once I think that this is looking good and I am ready to merge my changes with my main repository, at that time I can merge it. But till that time, I'm not sure what exactly I'm doing, what features I have created, whether it will work with my actual production or not. I can work independently. If you have any such scenario wherein you need to work independently without having a link to the target repository, then the right option is forking. How do I fork? Let me show you. If I click on fork, if you see, this is a new repository getting created, Valaxy DevSecOps.Mela DevOps. You can change the name to whatever name you want. It's totally up to you. Now, if you see this, this is a new repository getting created, and where you can create the repository wherever you want. So as if now, if you want, you can create a repository to your existing project. Which all branches? I just have master branches, but if you want all the branches to be forked, you can do the forking. Now I can simply create a fork. Now see, I got one more repository created. Now do you see this icon over here? Double a git sign. This means it is forked. This is your actual repository and this is a forked repository. Now if you see this, I'm inside my forked repository right now. It is exactly the same thing. Do you think anything do you see anything different over here? No. It is exactly the same thing. So as I said earlier, a fork creates a completely independent copy of your Git repository. Now imagine tomorrow you made some changes to your fork. For example, I just make it directly over here. Added new line, for example. I'm just making changes in my fork. Just imagine there is a new feature which you're done generating. Okay, I did a commit, a quick commit, and if you see, updated a file one. Now this is whatever changes you're doing, this change will not reflect over here. See this new line thing is not there. And if you see the updated file, this is not there. So it has nothing, no link, nothing. Whatever you're doing in the other forked repository, it's completely independent. But later, if you want to merge everything, there is a pull request which you can create. Let me go back. If you want to merge everything, there's a pull request which you can create and you can merge. I'll talk about the pull request and everything later. For now, this is what forking means, guys. Anyone has any question? Anyone? What is it? What is cloning? What is forking? Any doubt? No doubt, guys? Okay. Now let me go and delete the fork for now. So how do I delete? I can go to my project settings, left hand side down corner. I can go to repositories, and over here there's an option of selecting the fork, deleting the fork. Why exactly I'm deleting? Because there's no parallel development I want to do right now, and there are multiple other topics which we'll cover. Hence, I'm just deleting it right now. We'll create it later if you want. Okay. So this is about a quick glance. What is cloning? What is forking? Okay. Now this was about the file page. Now if you come to commits, you can see the complete history again. It's the same thing what you were seeing over here in the history. Now this is more specific. You can see more commits and things over here. Okay. And now if you see at the left hand side, this is a graph. This is a linear graph, guys, right now. This graph is visible from the top. If I just off the graph, here graph is gone. But let me tell you, graph is very much required. So use this graph option, okay? This is very much required. I'll tell you the reason where it is required. When we start doing the PR, you will see this graph. Now you got pushes over here. So pushes is basically what all things you have pushed to this master branch. So that history is also visible over here. So you can see who has pushed what, when was the thing was pushed. So if you see only one push we have done till now. This is the commit ID which we pushed. Now along with this commit ID, these are the local commit which got pushed. So if you want to know who pushed it, mail at DevOps. So this is how you can see who has pushed what to your master branch. Same way, if you want to switch to some other branch, you can switch it from here and you can see. Now this is the tab wherein you can have the branches, the list of branches. Now in this mine, there is only one branch, that is master. And in all, you can see there's only one master branch. In stale is basically the branch which has not been committed or used for last 90 days. That comes in stale category. Okay. So, and if you want to create any new branch, you can simply click over here. You can create a branch, like for example, develop. Remember when I was creating the branch locally, what was happening? I used to be in some branch, and when I was creating the branch, the new branch was getting created out of that branch. When all my files and everything was there inside that branch. Correct? Same thing over here. If you create a develop branch, you getting an option based on which branch you want to create a develop branch. So master is a default branch, hence you're seeing master over here. But if you want to change it to some other branch, you can change it from the drop down. It's up to you. Work item, this is something we have not done. After Azure Repos, we'll do work item. So work item is basically a user story or ticketing kind of thing, wherein whatever you do in your Azure DevOps, everything should be linked with the work item. So yeah, I'll talk about this. This is very important. I'll talk about this later after Azure Repos. We'll do work item. At that time, we'll see what exactly is work item. Okay. So I got a master branch and a develop branch. Similarly, I can have one more branch. I can have release branch, for example. Now, if I want release branch to be created out of develop or master, I can do it. I can select it from the drop down. I need to create one more branch. Let me create a feature branch. Okay, this is how the branches are created. I think there's some question. How would you change the default master branch to main instead? Okay, so this master is just because we have selected upstream. If you remember yesterday, that we have selected upstream and I had a local master branch. Hence, I thought of creating the same branch on my remote repository. But by default, nowadays, if you go to any remote repository, whether it's a GitHub, GitLab, Bitbucket, wherever you go, and if you create any repository, by default, a main branch gets created. There's no master concept now. So basically, this concept got removed because of master and slave thing. This concept itself got removed. Now everyone, whenever you create a default branch, it's the main branch which gets created. So there's nothing different, master, main, whatever you call it. So there's nothing much different. But yeah, the naming convention for the remote repository is changed. Whatever new branch gets created, it will be main now. Okay. Now let me show you. If I create a new branch, for example, let me see a test branch, test repo for now. See, I'm creating a test repository. As soon as I create a test repository, do you see the top main branch got created? So this is what will happen. No master. The master is because that master came from my local guys. I had my master branch on my local, and that is because I have an old version of Git running on my system. Hence, it created a master branch. But if I go and make changes to the configuration, then even on my local, a main branch will be created. But there's no concept change, nothing hampers. It's just a naming convention, guys. So don't worry. Master and main is exactly the same. Nowadays, we are not using the term master. There was a issue behind it. There's a history behind it. If you want to know, just Google and you'll come to know what exactly the history is. And so nowadays, we don't have this master concept. As simple as that. Okay, now these are the 4 branches which I have created, and all the branches are currently at the same level. All the branches are currently at the same level because we created all these branches from master itself. Now if you see, there is a tag over here, default and compare. Now this default tag, you can change it, guys. It's not an hard and fast rule that only the master or the main will be the default branch. No. If you want to change the default branch to develop, you can just simply come over here, change it. See, the default tag got changed. Now where do this default tag gets used? Now whoever clones this repository for the very first time, and if develop branch is set as default, so this develop branch will get cloned. You will have the develop branch changes. If you want the master branch changes, you can have it also. That's not a big deal, but by default you will get this develop branch changes. Okay. So, and whenever you create a new branch, you can see develop branch now, because this is a default branch. So wherever you will be using this repository, whichever is the default branch, that branch will get cloned. As simple as that logic. Okay. Now what is this compare thing over here? Now let me change the compare to master. Just the compare. Now see, the default change to develop and compare change to master. Now what this compare is, now to understand compare, understand this behind and ahead. This behind and ahead is basically giving you an idea how many commits this develop branch is behind from master, and how many commits this develop branch is ahead from master. So basically all other branches like develop, feature and release is doing a comparison with your master right now, because the tag of compare is set with master. Now if I show you, if I go and make a changes to any of this file, for example, just imagine I'm writing something testing compare. So I'm just doing a direct commit, guys. I'm doing it the same thing what we did locally, editing the file, doing a git add, then doing a git commit. This is what exactly I'm doing. Updated testing compare, for example. See where exactly the commit is happening on the develop branch. Now if I go back to branches again, do you see 01? Do you see the author got changed, the commit got changed? One means it is ahead. So I have one new commit in my develop branch, so my master branch is one commit behind. Okay. Same way if I make one more change over here, let's add something new. Develop file, something like this. Added new file. Okay, so I got this one more added. Now if you go back to branches again, you can see 2. So this counter will keep on increasing, and it will keep on doing a quick comparison with your master. Okay, you can change this compare tab to anywhere else also, guys. So there's no issue. If you want to change this compare tab to something else, you can do that. So this is a quick glance of what is the default, what is compare. Now this is your commit IDs. These are the author who has made the changes. This is when the changes were this is when the changes were made, and this is behind and ahead. This is status. Status will be visible when you will have your build pipeline integrated with your branches, and this is your pull request if there's any pull request created. Anyone, any questions? So till now, this is just a basic what we are doing right now, guys. I'm just giving you a walkthrough of Azure Repos, what exactly Azure Repos is all about, before starting with some new topics. Anyone has any question with this walkthrough? What exactly is default? What is compare? What is fork? Anyone, guys? Any doubt? Okay. No questions? No problem. Let's move on. You have seen the tags. So this is where you can go and create tags. This is one way of creating tags. And last but not the least, we got a PR over here. Okay, now let me start giving scenarios. What did we do when we wanted to merge changes with between two branches? So I used to go into that branch, the destination branch. Then I used to run the command git merge and the source branch. That is what we did last time from the command line. Now, what needs to be done in Azure Repos if I want to merge these two changes? If you see there are two changes in my develop branch. If you go inside your develop branch, if you see the commits, these are the two changes: testing compare and added develop file. These are the two changes which is not there in my other branches. Like if I want to merge these changes with my release branch, for example, from the top, if I change it to release branch, my release branch does not have these changes. If you see the commit. So how do we merge from develop to release in Azure Repos? So in Azure Repo, there's a concept called pull request. We call it as PR. PR is nothing but it's a form kind of wherein you put in your source, you put in your destination, you put in what needs to be merged and things like that. So this is more sophisticated way of merging changes with your destination branch. In command line, we were directly doing it. We didn't have any options of selecting what we are merging, getting approvals and things like that. But over here in PR, you need to fill in a form. Then using that form, if you want to have some code review done, you want to see what exactly is getting pushed and things like that. So it has more information as compared to the git merge what we were doing. Okay, so how do you raise a PR? Like just imagine the scenario that I want to merge changes from my develop branch, which is ahead, with my release branch, which is behind right now. Okay, so I can just have a pull request created. At the bottom you see there is an option of pull request. You can simply create a new pull request. Now this is what the form looks like. This is something we need to fill in. Now this is your source. Develop branch is the source. What is the destination branch? The destination branch is dev release. How many files? Differential file. There are two files. Develop file. These are the changes which is getting testing compare. These are the added new file. These are the two commits. These are the two commits which will be pushed into my release branch. You can give whatever title you want, merge to release. Description, you can give a description, or if you want to copy this commit messages which is there over here, you can simply click on add commit messages. Reviewers, work item link, tag, this is something for now, just ignore it. We'll understand this in great details when we understand policies. At that time, we'll understand all this. For now, I can simply go and create a PR. Now, if you see the PR is created, the first thing it checks, now this is the PR, guys, what you see over here, this is what a PR looks like. The first thing it will check there is whether there is a merge conflict or not. So if you see, there's no merge conflict right now, guys. So it's a very simple, straightforward, no merge conflict. At the top, you can see again the files. What are the files getting merged? You can see if there's any updates, and you can see the commits. These are the two commits which is getting merged. Okay, this is your description. And if there's any suggestion, like if there's a code review happening, like suppose if I'm doing a code review, and if I'm just giving you a review that check the syntax, anything as such, this is a review command I'm giving to you. So that comment and everything will be visible over here. See this. I've highlighted this code, check the syntax. Now being a developer, you need to go and fix it. If you're a developer. Okay. Now on the right hand side, you can see all the reviewers, tags, work item. Now, this is something I'll talk about, the importance of reviewers, importance of work item, and this all we'll talk about later. For now, we'll just focus on a simple PR. Okay. Now you have this develop into release. These are the two files which is getting merged. Now in order to complete this, you need to click on complete. But when you click on complete, there are 4 different merge type. Merge no fast forward, squash commit, rebase fast forward, semi-linear. Now this is very important to understand now. What is merge no fast forward? Now give me one quick minute. Let me open Git PPT. Now these are the 4 different merge type which you will find whenever you're creating a PR. Now let's understand what is the importance of this merge type is all about. Now the first merge type which you saw, what merge no fast forward. So the merge no fast forward is nothing but it's a default integration strategy in Azure Repos, GitHub, and most other Git providers. So this is the default integration strategy, guys. In this strategy, what exactly happens? All individual commits are preserved and a new merge commit is created. So basically what will happen, whatever history is there, the 2 commits, that will get preserved, and on top of it, you will see a new bubble of commit getting created, giving you a clear indication what exactly has happened. So this strategy is helpful because it's illustrates exactly how a developer worked on a pull request, including each individual commit along the way. Now, just imagine this diagram. You are right now over here. You clone this repository. What you did, you clone this repository, and these are your 2 new changes. These are your 2 new changes. Okay. Now you're ready to push. So these are 2 changes which you did locally. Just imagine. Now you're ready to push your changes to your remote repository. So what will happen when you push the remote repository? A new commit is getting created over here. And along with this, 2 commits are also getting preserved. So what exactly will happen? Let's go to the Azure DevOps. Okay. These are 2 new commits, which is there in a develop branch. Now what you're doing, you're merging your changes from your develop branch to release branch. Now if you go and see the release branch does not have those 2 new commits. Now what exactly will happen when you do merge no fast forward? Both the commits, both commits will be as it is, it will be picked from here and it will be placed on top of your release branch. Okay. Along with there would be a new commit getting created. Now that new commit will be a clear indication that a merge no fast forward was done over here. And that new commit will have all your changes. So this commit, what exactly this commit is doing, it is preserving history. So you come to know like what was the commit done, who has done the commit, what exactly the file was, and what was the code, and everything you'll come to know. And on top of it, you will have a new bubble like a kind of structure will be created. A new bubble like of structure will be created. It is very helpful as you will know who was the developer and what changes development he did, and it will preserve all your individual commit. So in Git repositories guide, preserving history plays a very critical role. If you want to backtrack what exactly has happened, so you will be doing that backtracking only with the history. And if you don't have history, then you cannot backtrack. Just keep that in mind. So preserving history in Git is very important. So this merge no fast forward is basically preserving history along with creating a new commit bubble for you. Now this is hence the default integration strategy in many Git remote repositories. I would say in all, even in Bitbucket, you will find this same strategy. Okay. Now let me show you, then you'll understand more about this. So let me go and complete this pull request. So I'll click on simply complete. I'll select merge no fast forward. So merge no fast forward is, if you see written over here, it's non-linear history preserving all commits. Now why this is non-linear? Okay, I'll show you why it is non-linear. Okay, done. Let me complete it. Okay, it might be done for now. Let's go to the release branch. Now, do you see this? This was the previous commit which we had it in release branch. Now, this two new commit got added. From where did this two new commit got added? This is from your develop branch. Along with you have a new merge commit over here. And if you go inside this merge commit, you can see the exact same change. Now, why it was non-linear? Do you see this graph at the extreme left? What this graph is showing, this point, file 1, this was the old commit which we had it in release. Now this 2 point testing compare adding new file, this is the new 2 commit got added from a different branch. And along with over here, do you see this gray line, gray dot, not line, the gray dot? This is showing this is the new merge bubble got created over here. And this gray line over here is showing how the commit has evolved. And because this is not in straight line, this is called non-linear. What is linear? Now a straight line is linear, and this diversion what you see, because this commit was directly from here till here, this diversion is showing you that it's a non-linear commit. That's why this graph is very important. If I just take out this graph, you'll not come to know what exactly has happened. Now with this graph, you have a fair idea what exactly has happened, how the commit has evolved. Now along with at the right hand side, if you see, this was the pull request 10 which we have created. Now if you see in the completed tab, this was pull request 10. Okay, now the 10 is showing over here. That this is because of the pull request which you have created. There is a pull request number is showing over here. Again reiterating, this is merge, no fast forward. In this, the individual commit history is preserved and a new merge bubble is created. This is the default integration strategy in many of your remote kit providers. Now this is 80% of time in real time. When if you talk about real time, in real time 80% of the time this is the merge type which you will be using. So most of the time this is the merge type. If you don't know, if you have any confusion what to use, go with merge no fast forward. This is very safe, no changes happening, it is preserving complete history, along with it is also creating a new merge commit, so that if you want to see what exactly has happened, you can easily go and see it. Now if you go inside this, you can find the exact files, same files, from the exact same files you can see. Now if you see, this is your old version, this is the new version. This is side by side view. If you want to have inline view, you can have inline view. So in inline view you can see what was added, but I prefer side by side, guys, because as if now you just see 1 or 2 lines, but in reality there will be 1000 line of code, and inline will become very clumsy at that point of time. So this side by side comes very handy, because on left hand side you have the older version and the right hand side you have the newer version. So side by side plays a very important role if you want to view what exactly who has done what, if you want to view that. Okay, anyone, any confusion with this merge no fast forward? And guys, the way I am practicing, I've created a main branch, then I've created all other branches, then I just made changes to my develop branch, then I started creating a PR and started looking into PR, how exactly PR works. Okay, so just make sure you have it the same way. You guys can hear me, correct? Am I
Yeah,
audible?
yeah, we can hear you. Um, are you going to cover rebase as well?
Yes, yes, yes. I'm just coming to that part.
Oh,
Don't worry.
okay, I don't have any questions.
Okay. So this is the first merge type what we have. Let's go back. If we are good with this merge type, let's go back to the other merge type. Okay. Now, in order to test the other merge step, what I'll do, I'll create a new PR. Now this time I'll create a new PR using, I'll create a PR between develop and feature branch. Now if you see, the develop branch is 2 commits ahead and the feature branch is 2 commits behind. Let me do that. So let me again go back to the pull request, create a new pull request. Now this is develop, and I'll select my destination branch as feature. Exact same thing, 2 files, 2 commits, nothing different. Now merge to feature. Okay, now this time, if you want to do a quick glance how the feature branch commit looks like, see this. Exact same thing. See this tag. This is how it looks like. And if I go back to develop, the develop has two new commits. Okay. Now, if I go and complete, the other merge tab, what you see is squash. Now, what is squash and what is squashing? So squash, basically, if you read through this, it's linear history with only a single commit on the target. Now, what does this mean? Let's go to PPT and understand this. Now in a squash, each pull request becomes a single commit in master and there's no merge, just a simple straight linear history. I know no one has understood anything. Let me explain this in a very simple layman term. Now think of, you got a scenario that you got two branches, develop branch and a release branch. In your develop branch, okay, forget about this develop release. Just think of a scenario. There is a developer who has created his own temporary branch. Okay. Now this developer, while doing the development, he has done around 100 commits. While doing his development, like the whatever feature he was working on, while doing that development, he did around 100 commits. So that commit was all done on his local repository, on his temporary repository. Now he needs to merge everything with develop branch. Now develop branch is something which is getting used by multiple developers, not by just one or two developers. Okay. Now the problem is, if the merge happens, the merge, just to take an example, if you do a merge no fast forward, in that case, what will happen? All the 100 commits will become part of your develop branch. And your develop branch, there is a great chance that your develop branch may get commit, uh, may get corrupted, or may go out of sync, or XYZ could happen, because there is unnecessary development what the developer was doing, and because of that development there are unnecessary commit which is there on his local, and I don't want those commits to be part of my develop branch, because the develop branch, there are 100 developers who are using the develop branch. If I just keep getting all these commits from the local branch of the developer to my develop branch, then it will be very difficult for me to manage the develop branch. Now, how do we get rid of such issues? So in such cases, we can suggest squashing to the developer. Now, what exactly squashing will do? The squashing will squash all those 100 commits into one single commit. What exactly it will do? That 100 commits will get squashed into one single commit. And then that one single commit will be pushed into a develop branch. That one single commit will have all the changes what the developer has made. Whatever development the developer has made, that one single commit will have everything. Now, what is the disadvantage of using Squash? The major disadvantage of using Squash is the history is gone. You cannot backtrack what the developer has done, how the work has evolved, and things like that. And so if you can compromise on history, So that's why I gave you this scenario, because there's no need of getting what developer was doing locally and things like that. So if you can compromise on that part, then Squash is the option. Now let's go and read through the definition again. In Squash, each pull request becomes a single commit. As I said, it becomes a single commit, and there are no merges, just a simple straight linear history. Individual commits are lost. Very important, guys. Individual commits are lost, which is best for team who uses fix up. So as I gave you an example of development, just imagine if there's a bug fix, what the developer is doing, then we can use the same concept. And do not carefully craft individual commit for review before pushing them. Just take this example again. This is the clone you have cloned. This is how your work has evolved. And when you're done with your work, you simply merge the changes with your main repository. And when you're merging, if you see there's no link like this, that means there's no history preservation happening over here. It is simply, you just took all the commits, squashed it, and you created a new commit, which is over here without history. That is what squashing means. Use squashing technique very wisely, guys. If you are not sure whether to use squash or whether to use some other commit, don't use squash, because squash will delete all your histories. It will not have any history, and it will create a simple linear commit graph for you. It will not give any bi-directional graph that this is how the commit has evolved, like merge no fast forward. Nothing as such will happen. Keep that in mind when you're using squash. So by the word itself, squash, what is squash? Squashing. So that is what it will happen over here. Let's go and let me show you the squash demo, then you'll understand more. Okay, now this is squash. I'm trying to do a squash. Again, these are the two new commits, and if you go and look into feature, this is only one commit. Now let's do what will happen if I do a squash. Let's go and see, refresh this. Do you see what has happened? Pull request 11, only one single commit. Both this commit is gone. Your testing, compare, edit, develop file, it's all gone. You can just simply see one single commit. See this. You have all your files. The files are gone nowhere. You can see all your changes. These are the two files. You can see all the changes. But even if you go in details, you won't find anything. What was the commit? What? So there's no backtracking. As simple as that. And even if you go and see the graph now, it's a straight line. A simple graph, a linear graph which got created. Are we good with squash? Anyone? Any doubt with what is squashing? This is again a
I
very
think this is
interview.
clear. Sorry, I had a question. So if you squash, can you like add a comment like you can with the commits, so that at least you kind of still know what you did?
You can, when you raising a PR, there is an option of
Yeah.
description. So the description is visible over here, and
Okay,
the title which you give, so the title is given over here, merge to feature. So if you want to have anything as such, you can do it.
thank you.
You can describe it well. You can give it a title and whatever you want. But yeah, so if you're doing a squash, so squash has importance, plus it has advantage, plus it has disadvantage. The biggest disadvantage, it is deleting your history. So basically you cannot go and backtrack what exactly has happened. But yeah, there are scenarios. One of the scenario which I gave, wherein a developer is doing 100 commits. Just imagine if you put 100 commits in your feature branch, what will happen? Everything will go haywire. Your complete graph will look weird. So you should not do such things. In such case, Kosh is the right technique to use, basically, I would say. But yeah, surely this is totally up to you. No, not up to you guys. This is totally when you decide the branching and merging strategy. At that time, you will be deciding like what merge type you will be forcing the developer to do. So branching and merging strategy, this is something we'll discuss it on Tuesday, not Monday. Monday because we'll continue with Azure Repos on Monday. That is Monday India time, guys. So it will be Sunday night for US folks. Okay. So we'll continue with Azure Repos again. So there are two more types, rebase and semi-linear. Again, very important merge type, which I don't want to cover today because it will be too much for today now. But during this weekend, I want you guys to go and practice the same thing. It's all there. This is there in my assignments. Whatever I'm teaching you right now, it's there in my assignments. Make sure to go and practice, because if you don't practice, let me give you an assurance, you'll not understand anything. And this is just a beginning of DevOps, because eventually we'll go start when we start working with build and release and ARM and many other things. There's a drastic change in tool. Like in each 3-4 days, there's a new tool which will be introduced to you. So make sure there's no backlog. Whatever backlog is there, make sure to complete those backlog within this weekend, and you are up to pace and ready to take the new topics beforehand. Okay, so I believe that's it for me for today. We'll continue with Azure Repos again next week. I need couple of more sessions on Azure Repos. Post that, we'll go back to and we'll understand what is work item management. That is the target for next week. Let me know if there's any question, any doubt related to any topic before we wind up the call for today.
I have a quick
And just,
question.
yep, tell me.
You mentioned assignment. Where can we find it?
Is there on the portal? I have shared in the I've shared the assignment in the WhatsApp chat also. So if you go into the media option, you can see the WhatsApp chat. But the same assignment has been uploaded on the portal also.
Okay. When was it
Just go,
uploaded? I
not,
did.
yeah,
I
just go through it. If you don't
look.
find it, just no worries. Just go through it. If you don't find the assignment, just ping in the WhatsApp group. I'll share it again, or I'll ask the Valaxy admin team to share it again with you. Don't worry.
All right. Thank you.
Just go through on the portal. If you don't see assignment, just let me know. Okay, if there's no question, we can wind up the call. And hopefully I should get questions on Monday, guys, when you do practice. Okay, so when you do practice, I believe you will get a lot of questions because these are new things which we are learning. Okay, so let's see what we have on Monday, and let's continue with Azure Repos. Thank you very much. See you on Monday. Bye bye.